please send me my your, if you have any problem with login, please send these problems to my email. Email is this mhher@ou.ac.lk. Okay, then I will start this session. I think you can see my screen. This is a school to software development for engineers, EEX3417. Content of these slides are structured programming, modular programming, function-oriented design, NS chart, data flow diagram, then programming in C. Under this programming in C, declare variables, operators in C functions, arrays, pointers. First, I will explain about structured programming. Structured programming, I will explain about non-structured programming. Before these structured programming, the C languages and other mainly all languages are structured programming. Today's programming languages. Earlier, in I think in 1980s, there is a programming language called BASIC. It has line numbers 1, 2, 3, 4 like this, and then we can write commands in programs 1 and then 10 like that. If we want to include, then we have to write 2, 3, 4, 5 like that. But after this, we normally use 10, 20 like that. If we want to include between more than 10 lines, we cannot write programs. We cannot try to include, insert these ports. That is the main one problem, and then it has not within we will you can see in C programming, one task is do only one main block like that. That is not available in non-structured programming languages. I will explain now the structured programming. In structured programming, we made huge design divided into modules. That means divided into some smaller sections called module. And then these modules are further divided until this small module which can write clearly. Actually, it is one task. The lower level module is a small one task program. After that, we write small programs and then we test those programs, and after testing we can combine all these programs. That is the one approach is top down and bottom. Another approach is bottom up. Top down is first define the problem and then subdivided, further subdivided like that. Then small part we can write codes, small parts. That is top down. Bottom up is we write first small codes and then combine them. I will give examples in our textbook. 78. This is textbook 1. I think you all have textbook, and also you can see download from the textbook from the OULMS site also. Here this is top-down approach. This top-down programming is this is the main module combining all these submodule. P, C, D are submodule. These modules are subdivided further like this E, F. These two are top to bottom. This is bottom to up. Top down is also called decompression. Decompression means separating one problem into several modules. Here atomic is small amount from one to many. This is bottom up is concatenation. Concatenation is concentration. No, not concatenation. Concatenation. Concentration. Concentration is many small sections combined to give an abstract. Abstract means whole thing in one module. I think concatenation, concentration, not concentration, concatenation. Concatenation is adding all together. Bottom up is from here to here. This is we can. This is a modular programming. Modular is this main program subdivided into module 1, 2, 3 like that. Example is calculator. For example, calculator is main program. It can subdivide it into addition, subtraction, multiply, and division. That is for submodules, and these things further submodules. This is like example. This is one example. This we can write level 1, level 2, level 3. Update master file. Updating a master file. Get valid transaction. Get transaction, print error message, and then go back to the main program, and the fetch master fetch means loading the master record, and then the update master record. Update master record include 3 submodules: add record, modify record, delete record. This is stepwise refinement. In stepwise refinement, this is an example for stepwise refinement. That is also like module. This small module has the flow chart for one flow chart for a small module. Input A, input B, and then processes multiply A and B using addition. We can multiply by addition also. Value 0, I 0, and then check whether I greater than B. If it is no, I equal I plus 1. Then value is plus value plus 1. Value is first time 0, and then A input value. Suppose A is 2, we input 2 for the A, 2 into 3. Suppose we want to find the multiply 2 into 3. 2 into 3 is 6. Now here value is first time value is 0. Here also 0, and then plus A. A is 2. Now then this value has 2. This value is 0. 0 plus 2 is 0 plus 2 is 0 plus 2 is 2. And then check whether I greater than B. I is first time I is 0, then 1. Now next time I is 2. I is 2. Value is 2 plus 2. 2 plus A is equal to 2 plus 2, 4. Then go back to here, and then check whether I is now 2. This is not, this condition is not correct. So, no, I is equal to the I plus 1 means now I is 3. And then this become 4 plus 2. 4 plus 2 is 6. Then go back. Now, now I is equal to 3. Now I become, if I become 4, that means I become greater than B. So if it is yes, this exit. So value has the multiply A and B. First we write using a black box. We call it this black box, multiply AB. We can write either by addition or some other, if you want to find, if we can think in other method, we also can write inside this box. then end. Module has these properties. One unique entry point, input point, and one output point, and one logical task. One single task. Only module has a one single task, small. So we can further down modules, and ultimately small module, we select a small module and write programs. That is actually that modularizing is very easy when you program. It is manageable and we can easily find errors. In a program, there are we can write in several steps. This is a sequence. Step 1, step 2, step 3, like that. This is selection. Selection means check whether a condition, check whether A is greater than B or like that. If it is true, go to this side, or if it is false, go to this side. That's all things are we can test in program, the C program. Then iteration. Iteration is check whether condition is satisfied. If it is either true or false, go back. In iteration, go back. That is a we call it as a loop. Go back, go back, go back. It goes in a loop. So after this condition true, the program will exit from this loop. This is another method. The earlier one is another method for doing flowchart like that. This is another method: sequence, selection, iteration. We can write circle with white color is selection. This is iteration. This is sequence. This is end chart. Earlier, this is also a structure chart. This is called end chart. We can write flow charts like this, either MS chart, structure chart, or flow chart. Sequence, selection, iteration. If the selection is false, go like this way. If the selection is true, go this way. This is two sides iteration until y. This is called data flow diagram. When we design software, these are actually tools. These all are included in your textbook. The DFT and flowchart, structure chart, MS chart, all are algorithms, all are tools to define, tools to develop software. This is one type tool, data flow diagram. In data flow diagram, first time we write this called context diagram. The context diagram means one single circle or ellipse, and then entry, external entry. The examples for this is available in page 82, 80. This is a data flow diagram for booking books ordering system. Customer, this is actually level 1. This is level 0. This is level 1. Actually, level 1, no, level 0, DFT is just books ordering system, and then input. What are the inputs? Customer, warehouse, customer and warehouse. That is the only thing. Books. I will draw in customer. Books ordering system. And then what are the other entity? Warehouse. These both are same entity, and this warehouse. This actually warehouse is only inputs. From the warehouse, it is only inputs. This has both like this. This is called context diagram. Okay. Here, this is level one. Uh, level one diagram. These are the main elements to draw the data flow diagram. External entity, process, data flow. If you want to store data, you can indicate like this. Now these processes, now say ordering process, ship books, we can subdivide these modules. This is actually level 1, and we can further subdivide it into level 2 also. Like that, when you subdivide it into level 7, up to level 7, mostly that is enough for the huge uh, huge system. After subdividing into level 7, it is enough. Uh, uh, Mostly, it can manageable. This is another data flow diagram. These entities are continuous assessment, is all are students' stores. And this student is an entity also here. Process, eligibility selection, exam processing, marking also. Can you say anyone what is the level of this data flow? Can you say what is the level of this data flow diagram? Oh, well, yes, this one. What is the level of can you chat? Oh, chat. Can you say? Yes, one has written level 6 to 10. One has written level
Level
2. Yes, level. What is the level?
level 2, sir.
Yes, level 2 mean we can write process 1, 2, 3, 4 in level 1. Context diagram level 0. This is level 1. When we write the level 2, process 1 become process 1.1. Process this process become 1.2, 1.3 like that. Uh, here this in this process in level 2, 2.1, 2.2 like that. If you further subdivided 1.1, 1.1.1 like that. Here it is like this 1.1, 1.2. Okay, now uh, data flow diagram and all those things are finished. So we will start programming with C language. We have to study integer numbers, floating point, characters, logical, that is Boolean, logical items. Int mark 1, int mark 2, int mark 3, int. Okay. We will start by okay, now, yesterday, in a earlier day school one, one student asked, "What is this called preprocessor?" I will explain why like this. Okay, now here int a int b equals 0, int C equals 0, enter A, then integer D, A. What should write here? Can you explain what should write here in this one? Anyone? At the end of each line, what we have to write?
Semicolon.
Yes, semicolon. Semicolon. Printf enter B, semicolon, scanf enter no. Here in this program, the process is S equal A plus B. Then printf some answer. We have to write here D, comma S. In printf command, this is variable, this is answer. We have to write this. This is called qualifier. By writing this command, it indicate that where should it print. Suppose answer is answer D. Answer this. We will write like this: 3 minuses. But here in scanf, we have to write and sign C, comma, and D. By we have to run it. S is no. S now what is the problem here? S is undeclared first used in this function. We declared 3 variables here: int A, int B, int C. But we have written S here. We have to change either S or C. I will change S. C instead of I will write S instead of C. Check whether it is working. Now enter A. 2, 3. Now answer is 5, and these symbols are there like this. This integer D indicates where should it print. Suppose we write integer D here. You can see these 3 lines are left side to the file. Now we can write hello. Now we can write these in declaring variables in separate file. This header files we will write like this. Then we can delete it. We can include them, this file, using inverted commas, b.h. Okay. Now, this customer header file. We write in integer variables here, and then run the program. The same thing answer will be given. Yes. Now, using these header files, we can separately write separate modules and then combine all of these modules into the main form. Wait for a minute. Now, is the variables integers. Now we will write this program. In this program, we will create a new project. And in this one, this is comment. This is comments are important to describe what we write. This is my program using variables. Right here, x slash star mark, and this is my program, my program using variable. Within these lines, the compiler actually, when we after writing these programs in editor, we have to compile. That we have to run it. When we run when the system running the using the compiler, it first checked whether errors are there. Then if there is no error, directly it converted to the machine language. When changing the machine language, within these commands, within these lines, all these lines are ignored by the compiler. Include void main int work days equal 5. Plot work hours equal 8.5. Now this, if you declare variables as plot as plot, if you declare this way, this is called variable. Variable is, we can write a name and we can assign several values into this a value we can insert a value, but the type of value is depend on this data type. And this if we write this plot for this variable, we can write like 8.5. If we convert this, if we write int here, the only 8 will be assigned to this work hours. Plot pay rate. Pay rate is plot weekly pay. Now equal weekdays into work hours, work days, work hours, pay rate. Now work days. Now after defining first variables, it will display these variables. Work hours into multiply pay rate. Now we can define here also. Now weekly pay is not defined earlier, so we can directly define here also as plot. Printf weekly pay equal rs integer f integer f weekly pay. Semicolon here. Now this f pin f defined here because weekly pay variable is defined as plot. If it is plot, we write here as F. If we write int, data type is int, we write D here. Okay, return 30. Now we can run it. Wait. See, if it is return, if we write return 0, we have to write int here. Without return 0, you can write void here. See, the answer is here. Okay, now in these decimal places are how many decimal places? 1, 2, 3, 4, 5, 6. Now instead of this 6, we can write only 2. We can limit 2 decimal places by writing this. Here, only 2 decimal places. And then, what else? Okay, right. Do you want to practice it? You can practice it by using online gdb.com. This one. I will copy. This one, then I will share. Okay, you can do copy paste. You can do. I think I will share this, and you can copy. I will using this document. You can using this link. You can get this Word doc file, and you can copy and you can test this program. We can actually directly copy, but if you want to check errors like those things, only all those things one by one, we can write. Other thing is logical operators in C. And these are the symbol for and is both should be true or false. Logical or either one is true, it will true. Logical not is if it is if false, if the expression is true. That is, this is these things we can write in C program like this: expression 1 and expression 2. Expression 1 we have to write like this and not like this. We will test this also. This is actually image. Seems. Include int main void int ca. I will write without these comments because it is easier to write program int final mark. Printf enter ca marks. Here actually we have to initialize, okay, to 0. Otherwise, sometimes the garbage value may be inserted before actual value we want. Enter scanf integer is ca. Integer ca. Printf enter your final mark. It should be this one, final mark. We have to write n here. Uh, uh, we values of ca here will be goes to address of this value. That is the address because we indicate array address by using this and sign. If ca greater than if ca greater than or equal 40 and final mark greater than or equal 40, then you have passed the subject. Printf, you have passed subject. Otherwise, else. Okay. If else, printf, you have Not pass, failed, not pass the subject. Whatever here, it will print. Enter CA marks. 35, 40. You have not passed. Here, this if A, the expression A and expression B both should be satisfied. Suppose if you write like this, if you write that is O, either this one satisfied or this one satisfied, it will okay. Now according to this, you write N. In C programming, this indentation is not needed. But to read the program clearly, you should have to put the indentation clearly. Indentation, sorry. Where this indentation should be, wait for a minute. Mm, okay then. This slash n, one student has put this, what is the slash n? Slash n is, okay, now we will write like this. Now, uh, now see the program like this, okay? Enter CA marks, final exam. Now you have passed the subject. This is uh, uh, one line. It will print in one line. Okay. Now, if you want to print in 2 lines, you have passed. Then in the next line, it will write the subject. Now, to do this, you have to write here /n. 40, 40. Now see, you have passed, then the next line, it will print the subject. That is slash n need to go to the next slide. Next line. Okay, understood? Kushan. Okay now? I think you have not get this line in chat area. Now, can you see all of you the link of this Google Doc? Now you can right. Most of you look in this. Another thing is all these things are available in book. Programming with C language here. Welcome.
Excuse me, sir.
Yes.
So when we write the programming, why do we put that add double add in between the writing coding, sir?
Double and for this one.
Yeah, sir. Yeah.
This is and.
Okay.
Both these condition. One condition is C with check whether C is greater. This is greater than or equal. This is greater than or equal. Okay. It check whether CA is greater than or equal 40. Then it check whether final mark greater than or 40, equal to 40. If it is both conditions are okay, then it will go to the this slide, this branch. Otherwise, this goes to this branch. Oh, suppose we write like this. What will happen now? Now, if it is CA is greater than or equal,
Excuse me, we cannot see your screen, sir.
you cannot see.
Yeah.
Now, or from the earlier also.
From the earlier also, sir. We can see only the course material.
Sorry, why didn't you say? I will share screen again, okay? What happened? Now?
No, sir.
Now, is it okay?
Yeah, sir. Yeah.
Right. Now, from which slide you couldn't see this program? You couldn't see.
That you put and double at the, I think, the CA test programming, sir.
Until
CA.
that, it's okay.
Yes, sir.
Right. Okay. Now I will explain this. Now, if we put the O here, CA greater than or equal 0, final mark greater than or equal 40. Either this one satisfied or this one satisfied, it will indicate this. You have passed the subject. You can see 40. Final marks say 35. Now you have passed the subject. Now suppose we write like this, and 40, 35. You have not passed the subject. It will go to the this branch because final exam is 35. This is not satisfied. If we write end, double end, that means end. That means both of these should be satisfied. Now is it okay?
Yes, sir. Yeah. Thank you, sir.
Now how about others? Okay, I think you can understand. No? Now you can see, no? Now you can see this slide, no? Can you
Yes,
see
Yes,
it,
sir.
sir?
Yes.
Yes, yes, yes. Tell me.
We can see this slide, sir.
Right. Now these are called increment or decrement. So remember this symbol plus plus, plus plus, minus minus. Example, plus plus before x, plus plus after x, plus plus before x, plus plus after x. Okay, now I will explain by using a C program. Right. Now in C, without this indentation also usually okay in C program, but you cannot, it cannot readable. C equal 5. Printf integer D C. D C. In this compiler, no need actually this slash n, because after end of this printf it now for the printf it need /n need. When you write scanf, it is not needed. Printf integer c. Then C++. D /n comma C++. Now in this one, this before this execute, it will print C. Then plus plus execute. Plus plus is add 1 to this value. Plus plus is add 1 to this value. But after the operation, that means after printing the C value, it will add. That means 6. It is 6. It will become 6 after printing this value. Now see, printf C. There are two files. Okay. Now this printf C is C because C is file. This will print file. But here C++, it will add after this printing this C. Now printf. Printf integer D -n comma C. What will print here? Can you say now, anyone? Now, in this first one, it will print directly the file. Yes. 5, 6, no. 565 is not correct.
556.
Yes, 556. Because here, before plus plus, before adding, it will print. Then after this print statement, this C becomes 6. Okay, now we will write it. Then we will run it. 556. Now again we will write C equal 5, C plus plus C. Now what will happen? Now here it will print C directly 5. Before printing, it will add. And then here also, now it will print just C. You will write /n here, okay. Now here 5, 5, 6. Here 5, 6, 6. 5 add before printing, and then add before printing and print. It will print 6. Then print just C, that is also 6. Now what will happen? Now I will add now what will happen if you write minus minus, right? Can anyone answer? What are the answers? What are the answers for this one? 5, 5, 4. 5, right, 5, that is, okay, most of you have written correctly, okay. This is the answer, 5, 5, 4. Then 5, 4, 4. Right, okay. In this one, if else, if else if condition, what is this actually equal? So this command is, this operator is equal sign. Check whether it is equal to the value 1 and 2, value 1 to the 2, value 2. So we can write not equal, equal, greater than or equal, less than or equal. Okay, right. Now then, if statement, if value 1 check with the value check with the value 2. If after the if statement, if only one line, no need curly bracket. If there are more than one lines, you need curly bracket. Printf value 1 is equal to the value 2. Else printf value 1 is not equal to the value 2. Value 1, say 23. Value, if it is value 2, 23, value 1 is equal to the value 2. Otherwise, it will print value 1 is not equal. Say this one, if you write, we have not check whether value 1 is not equal to the value 2. Not. Value 1 is not equal to the value 2. We can write if we can check whether value 1 is greater than or equal to 0. Value 1 is greater than or equal to the 0. Value 1 is greater than 0. Value 2. Less than value 2. Value 1 is less than value 2. Now we can write less than all, right? Like this. Now these are the in if statement, check whether two different expressions are whether equal, not equal, or like that. We check. This is called selection. The next is iteration. Okay. In iteration, uh, it the program check whether a condition true or false. Until this while mean until it is true, it goes to the loop. Otherwise, it exit from this loop. Here, while x less than 3. Okay. Now we will check in this. Now, one student, Madara, have written just one sign, one equal sign. Yes, one. If it is one equal sign, mean it assign. In A1. Here we can write E1 equal 5. That is 5. Number 5 is assigned to this A1 variable. That is different with the difference between this double the two equal and single equal. If we write single equal, if it is assigned, numbers are assigned to this variable. Understood? Okay. Int x equals 0. While x less than 3. Usually, there are keywords in C programming. Here, keywords are displayed in green color and blue color. White color, these white colors are variables, but integer also it's in white color. Keywords mostly like while, if are in we can see in with brown color. Printf before increment. With a d x. The slash d mean it will go tab, not the next line. Slash d mean x plus plus. Printf after increment. Now, what happened when we run this? The first loop before value of x before value of x. First time x is 0. Now, while it is check whether x is less than 3. Yes, it is less than 3. So we'll print before increment x. X is 0, x plus. So after that, it will print 1. The second one, 1, after that, it will increment, then 2, it will print 2. Then it will check whether 2 is greater than 3, yes, less than 3, it is true. So it will add, print 2, and then add 1, it becomes 3. In the fourth one, now 3, check whether 3 less than 3. So it is false. Exit the loop. I will write like this without this directly end. What happened here? Right. Before increment, before increment 0, after increment, this is by using this T, it will go to a tab, and then slash n mean in the next line. Before increment 0, after increment 1, then before increment 1, after increment 2, before increment 2, after increment 3. The next is 3 less than, check whether 3 less than 3. So it is false. So it will, the program will exit from this while loop. Okay, what is the chat? Something which still matters me is why do we put an in front of the and in front of the variable that mean and in I think in scanf I think no. And why do we put slash this one? stdio.h without this, say this is a comment. We will test like this. Now, now here warning. Without this printf, I mean this printf input output commands are not working, but in new compilers it will work. Even this stdio.h is not a we didn't write. It will print, but with the warning. But in earlier days compiler, So the printf will commands will not execute without this stdio.h file. Actually, stdio is another document. We can write like this also. This we will write in x. We will delete this. Or we will write in text in another file, another file called s.h. We can include here, include within inverted commas of s.h. Now, before this process, this program run, this s.h will add to this program and will run. Will compile this with the main program. Now that's also okay. Now without this, say without this, yes, now x is not undeclared. Where is this s x is declared in this this file. Like this, we can write programs separately, some small modules separately, and compile together. Is it okay now?
So excuse me.
Yes.
So when you write coding, how do you decide here you put slashes and the T in, like, how do you decide, sir?
That is according to the what we want in the screen. If you want to screen, if you want to display screen in one line with the spaces, we can write T. If we want to write it is in the next line, we can write N. That is according to our requirement. Now, if you want down here, if we want line by line, we can write /n here. Now, here like this. That is, if you look, that is look. If you look better this way, we can write this this one. If we want to, if we think this is the best way, we can write this. That is depend on your thinking and your feel. Is it okay?
Okay, sir. Thank you.
Excuse me, sir.
Yes.
When we write code in an external file, does it we have to save it as .h, sir? .h?
Yes, .h, yes, header files. And we can compile other C programs also together. We can reprocess it if we want to include before this program. We have to write H files. We can combine many C programs also parallel, like not serial. And then what else? You test this exercise and for loop. Other thing one is for loop. Okay. for loop, in main, in number, in sum. Int main, int number, int sum, somewhere for number equal to 10. Number less than or equal to 100. Number plus equal 10. Sum plus equal number. Here, for number starting from 10 until the less than or equal to the 100. Add step by 10 to 10, 10, 20, 30, like this. Here, this is number 10, 20, 30, 40, 50, 60, 70, 80, 90. This increment by 10. Okay, but until number less than or equal to 100. If it is 100, then the executive will, the loop, for loop will exit. But here, number starting from 10. Now it is printf. The sum is, now first the number is 10, then sum is 0, the sum also become 10. And then next, the number become 20. 20 plus sum is already 10. 20 plus 10 is 30. Like that until the number is 100. The for loop will execute. After that, it will exit the for loop. We can write number plus plus also. Number plus plus at 1 by 1. Uh, 10, 11, 12, like that. Increment by 1. Now do the exercise, this one, and there's no time to do this exercise. Write C program to find sum of even numbers between 1 to n. The other main thing is functions in C. In C, you can write functions called and separate program that is like module. We call it as functions. We will write this. It is the okay. Uh, we can write this function before the main program. This is main program. This is function. Okay. We have to write if we write the function after the main program, we have to declare like this. If we write before the main program function, if we write addition function before the main program, no need this line. We will write this line first. Int addition, int number of bits, comma, int number of walls. Now, int addition, int total, Right now, this is a function. Now this is called function. Okay. Now we call this function from the main program. Now we will run it. Okay, now the function is now we can write actually like this also in total. We can write this program like this also. All right. Now int total is defined. Number of beds equal 5. Number of walls 15. And the total is number of beds plus number of walls. So answer is this one. So we can write same thing like this also. Like I'll say int answer is addition. Right. Here, so here uh, there is a separate section called addition. Okay. Now input parameters to this addition functions are number of beds and the number of walls. Data type of these variables are integer type int. And then the we call function from the program, main program, like this: addition 5, the two values 5 and 15, and then there is a return value here, return total. Return total goes through this variable, this data type. This data type, return data type, should be equal to the same as this this variable, data type of this variable, int. If we write this here, this plot as plot, this also should be plot, but here it is integer. The answer return total is assigned to this one. Okay, now we will run it. Now addition plot. This answers integer. The answer is integer. No? So it is now sending value is plot. So return getting value is integer. So it is different. So it will get error. So int value, int. We also need int. Now it's okay. Now here we can call this addition again. Suppose int n is 1. An is 1 equal addition 4 plus 30. Suppose this value, printf an is 1 equal integer d. Here we write an is 1. Now what will happen? Now we will put slash n here. Slash n. Now here, first we call this same function twice. Okay. Now addition the parameters input to this functions are 5 and 15, and the return value is from this one, total. This addition equal total, and this return value total here. And in the second one also, 4 plus 30. It will 4 and 30 will pass to this function, and this data type also should be same. Okay. Here int and n is also integer values. Here these are also integer values. Say we will write this one 4 point. It will work. Okay. Now even we insert 4.1, what is it? Return function for each code. Do we use the return function? Yes, in each function we should have a return value, but we don't in function there should be return value. Now, if we put 4.15, it will work, but we will not add even 4 point, the answer was for this addition is 34.15, but it will not. Only 34 will print because these data types are integers. Int return value, and then in one function, when we write one function, if we want to call in several times, we can call several times without wasting codes. Now we have to write several codes here now. So no need to code, just call the function and call this function and get the answer for different values. We can write this one. We can write this one at the beginning also. Here also, like no need this one. This code, no need this code. It will call. We can write a function before the main program also. And also, we can write function separately. Here. So we can no. In more main program, include s.h. Now it will compile before that. Yes. Now using both these files, the program will compile. Other thing is array. In there's a question in chat area. Can I change my lab session to Candy in same date? Not same date because still not assigned. So do we have WhatsApp? No. According to my knowledge, we don't have WhatsApp group. If you want, you can create and send me also. Other thing is the data structures. Actually, data structures are array. We do data structures with array. Okay. Now array. int number array count for count equals 0 to less than 10. Count plus number array count equals 0. In first for loop, only the zeros are assigned to all now. In this number array, it is like this. Array has consecutive, we can input consecutive 10 numbers, okay? Consecutive 10 numbers in one array. Here index is, we can write 0, 1 to 9. Now, for loop is write like this: printf count take a d dash n count. Now this will print 0, 1, 2, 3 like this up to 10. Here up to 9. 0 to 9. Number of digits are 10. 0 to 9. Okay, now we will assign these numbers to the number array. Number array within square bracket count equal count. Number array, this is the index. Okay, this is number index is 0 to 9. The maximum size is 10. 10 is 0 to 9. Now it will assign the count. The first time count is 0. 0 will assign to number array of 0 element of the array. After that, first element, second element, like this. Now we will print like this. Here also we can see number array count. Take a D. You can write T. This cycle they will print in one line with a tab. Okay, we can print like this. Count plus 1. If we write count plus 1, the zeroth count plus 1, that means in the first time, one will goes to this number array 0th element. Here 1, 2, 3, 4, 5, 6, and 9 up to 10. Okay. Now it is array. Now these are struct. This is okay, right, thank you. There are few slides here. I will explain these few slides. Okay, now I will explain now. Struct, okay. Now this struct are we can insert several data types into a one data as a one data type. This data type is struct student. There are 1, 2, 3, 4, 5 variables. Now 4 variables in one data type. Struct student. Okay, we will write like this. We can write struct student char name. Here char name is this the data type of this name is char characters. We can include numbers and both numbers and characters in this type of data type, but we cannot add to that means 1 plus 1 is equal to, like that we cannot add calculate, we cannot use for calculation using char data type. But if you want to include characters, we need char data type. Char, this is char array. Char name, what is the size of this? 55. Char NIC number. n. I will put only these two because now the time is past, so I will put only two names. Now in main program we can write like this: struct student, struct student. Student is this one. Student is this one. Struct student. That is student one is, we can write S1. We can write we will write int like this. S1 dot we can input data to this this variable in student structure like this. This instance of student struct is S1. I think it is somewhat difficult. S1 NICN is like this. We can write printf NIC integer D S1 dot NICN. Right here, this struct is like this. We can write if we want several variables in one variable. We can write as structures. This the new variable is student. Student has two basic variables, char name and int NICN. And we can we can create one object like struct student, one instance of student, because then we can write S2 also. S2 also. And S2, we can put S2 NICN equal 333 like this. Printf NIC integer d, comma s2 nicn. We can write like this also. Here we have to write slash n. Oh, yeah. The one variable, two instances. String copy is if you want characters. Now here, char name no. We cannot assign directly name. We can write. We cannot write name. Name is equal to the say. We can write. We cannot write like this. So we have to copy string copy. For string copy, we have to include string.h. String copy s1 dot name comma ss. Printf integer s s1 dot name. Now we cannot directly assign values to this. We call this as strings. If it is more than one character, it is a string. So we cannot directly assign values to name. So we have to string copy to this value, this variable s1 name.
Sir,
Yes.
sir, එතකොට මේ දැන් අපි මුලින් define කරද්දී මේ string copy එක පාවිච්චි කරන්න ඕනේ නෑනේ. ඒක පස්සේ පාවිච්චි කරද්දී ඉතල ගන්න ඕනේ.
ඉස්සර define කරනකොට ඕනේ.
පස්සේ ආයෙ වෙන තැනකදී පාවිච්චි කරද්දී ඉතලයි ගන්න ඕනේ සර්.
ඔව්.
හරි සර්.
මෙතන තියෙන්නේ string copy මෙතන NIC එකක් චානේ අරන් තින්නේ. මෙතන year of birth කියන එක විතරයි integer වෙන්නේ. email address එකක් චා. එතකොට මෙතන string copy student මෙතන තියෙන්නේ මේ instance එක student1 කියලා අරන් තියෙනවා. මම අරන් තියෙන්නේ s1 කියලානේ. s1 s2 කියලානේ. එතකොට දැන් මේ වගේ S1 එක දැන් මේක යන්න පුළුවන් object oriented විදියට ගන්න පුළුවන්. structure C වල object oriented යන්න බෑ. නමුත් මේක තමයි තියෙන object assign කරන්න. එතකොට S1 S2 ඒ විදිහට ඕන දාන variable එකේ variable type එක student data type එක. student කියන එක combination එකක්. ඒ කියන්නේ basic variable වල combination එකක් තියෙනවා. ඒකට මෙන්න මේකේ integers තියෙනවා. integer කෙලින්ම මෙතන integer එකට මේ දාන්න assign කරන්න පුළුවන් value එක. string copy කියලා තිබ්බා. ඒ කියන්නේ string එකකට මොකද්ද මේ characters වලට කෙලින්ම මේ direct දාන්න බෑ. ඒක නිසා string str copy cpy කියලා දානවා. printf with int එක s කියලා දාන්නේ string එකකට. ඉන්න. හරි නේද ඒක?
හරි සර් thank you.
මේකේ pointers කියන එක තියෙන්නේ එන්න මේකෙන් explain කරන්න. pointers දැන් array එකකදී all the variables are in a consecutive address space. Like this. First is base address in 100, 101, 100 and in the consecutive address space, all the variables are available. In linked list, this is a link. This is called linked list. These data are included in different places in memory, but it is linked with others. This one is called pointer. This one instance is called pointer. Pointer, we can create pointer like this. This sign indicates P1 is a pointer, and the result is integer value. This star marks P1 is a integer pointer. The pointer's data type is integer. Result also integer type. So we assign result is 10. So we assign 10 to the result. So we address of the result. This indicates the address of the and indicate the address. Address of the result goes to the P1. This is in this one P1 is a pointer. Result is an integer. Now we assign 10 to the result. So P1 is now using this P1's address combined to the result. Now in a linked list, one is like this pointer. These pointers, the first point address of this first point is 100. Okay, now the value is x. The next address is 125. In the 125, y is there. Y is y. This is data. And the next address is 150. In 150 address, y the data is y. And the next address is 175, like this. Okay, I think I will finish this day's call. I think last slides, I think these slides may be difficult to understand. I will explain it later again. This pointer, struct and see. Okay. So do you have any other questions? So then shall I wind up this session? Okay, then thank you. My contact number is my contact no. My contact number is this one. Wait, I will copy this. Can you see? Okay, okay. Okay, then thank you. Then I will stop this session.